Greetings, ladies and gentlemen. In this video, we are going to solve this question. We are going to solve this question. The question reads, two successive crests of an approaching water wave are separated by distance of 1.6 meters. It takes 0.25 seconds for one crest to cover the distance of 1.6 meters. Question A, at what speed is the wavelength? At what speed is the wave traveling? So the question is carrying two marks. We move on to question B. Question B, what is the frequency of the wave? So this question also is carrying two marks. So the first thing that we are going to do to solve this question is to identify the crests or to know the crests. Okay, so I am going to draw the wave here. So we are having the wave like this. So what are crests on this wave? So the crests we are talking about is this one and this one. So these are two crests we are talking about. So we are told that the distance between this crest and this crest and this one is 1.6 meters. 1.6 meters. Okay, so this distance also is called wavelength. This distance also is called wavelength, lambda. So this lambda is representing wavelength. After doing this, we are going to answer question A. We are going to say question A. We are answering question A. We are going to say speed is equal to distance over time taken. Distance over time taken. So I am going to come up with a simple data collection. So what are we having according to the question? So as we can see, according to the question, we are having I'm going to say data. So what data do we have? So as we can see, according to the question, we are having the distance. So the distance we are having is 1.6 meters. 1.6 meters. We are also having time. The time we are having is 0.25 seconds. 5 seconds. So this is the time we are having. So we are going to plug in these values in the formula. So we are going to say speed is equal to 1.6 meters 1.6 meters over 0.25 seconds. 0.25 seconds. So if we evaluate here, we are going to have 1.6 meters divided by 0.25 seconds. We are going to have the speed of 6.4 meters per second. Meters per second. We should not forget the seconds. So as we can see, we have successfully managed to answer question A. Let us also answer question B. So question B, the question is saying, what is the frequency of the wave? What is the frequency of the wave? The question is carrying two marks. So what you do, we are going to use two formulas. We are going to use two formulas. So, by the way, we are answering question B. So first, we are going to use this one. We are going to say frequency is equal to velocity over wavelength. So what do we have according to the question? So the velocity we are having, so we are going to use speed we calculated in the previous question as our velocity, which is 6.4 meters per second. Then the wavelength we are going to use, the distance we had in the first question, which is question A. So the distance we had in the first question is 1.6 meters. 1.6 meters. Now let us plug in these values. So we are going to say frequency is equal to the velocity. The velocity is 6. The velocity is 6.4 meters per second over 6.4 meters per second over the time, over the not the time, but over the wavelength, which is 1.6 meters. 1.6 meters. So we are going to say the wavelength, the frequency is equal to if we say 6.4 divided by 1.6, we are going to have 4. The units for frequency is hertz. So we are going to have 4 hertz. So this is the answer for question B using this formula. Let us also answer question B using this formula. So I am also going to say frequency is equal to 1 over period. Frequency is equal to 1 over period. What is period of the wave? So the period of the wave is the time taken for a particle to make one complete vibrational cycle. So like I said, if we are having the wave like this, then here we are having the crest, and here we are having the crest. So between the distance between these 2 points is 1.6 meters. Is 1.6 meters. So if we look at these, if we look at this distance, we are going to come up with a complete wave. So our answer, our speed, our period in this case will be period which is being represented by t, is equal to the time taken to complete one wave was 0.0.25 seconds. This was the time taken to complete one uh, one uh, wave. So we are going to plug in the value we have. So we are going to say frequency is equal to 1 over the period, which is 0.25 seconds. So the frequency is equal to 1 divided by 0.25. We are still getting 4 Hz as our answer. So this is our answer for question B. So as we can see, after using two formulas, but we are still getting the same answer, which is 4. Thank you very much for watching this video.